Hello, my name is Pat Curry with Arizona Generator Technology. We were the supplier for the emergency generator set that backs up this building. We are currently in the fire command room where we provide enunciation for the generator set and the transfer switches. This will be the enunciator that you'll have to give you what conditions the generator's in, what state the transfer switch is in. If there's a fault or there's an alarm, low fuel, high water temp, low oil pressure, those alarms will be displayed on this screen. If there's an issue with the transfer switch for position or voltage, it will give you an alarm out here on this display. The display has a test. You'll hear that. Since this room is unoccupied, it's probably going to be the responsibility of the front desk or security, probably to notify you when there is a condition. The generator itself will also have an enunciation and an alarm locally. So I'm not sure where your office is located, if you're back by the equipment room in that area, or if you're walking by the louver, you may hear the horn going off in there also. The alarms are set for battery charger failure, low battery voltage, high battery voltage. You're going to have gen power, so anytime the generator is running, this indication light will be on. Line power, system ready, and comms talking. You will also have a low oil pressure shutdown, high water temp shutdown, low water level shutdown, overcrank, overspeed, loss of RPM, and generator running. And then you got an e-stop and not an auto. And then you have all your pre-alarms over here. Not an auto is when a technician's on site doing service. He'll take the generator with your permission when they're here, lock it out. So while they're working on the engine, changing the oil, doing service, checking the belts, to prevent a start without them knowing about it while they're on the equipment. Transfer switch control, you touch screen, oops. Let's see, you see a touch screen, gives you the position graphically of exactly what the transfer switches are doing. You hit that, gives you your voltage, position, and your run hours on that transfer switch, knowing the condition. Transfer switch also has the ability to manually start the generator set here for fire command, run the generator, and also go to emergency if they so choose during an event. To hide those controls, just go back there to get back and go back to the main screen, and that's it for the display. It's all HMI, the password's all set up. I'd have to probably tell you what the password is. I don't know. I'll have to get the manual. I looked inside, I didn't see the manual, but I know there's a manual in the operation maintenance books that were turned over to CCON. But other than that, in the event you have an alarm, you can silence the horn right here. It will silence it here. It'll still go off at the generator set. Once the fault is corrected, then it will clear it here. But if the fault's not correct or another fault occurs, the horn will reactivate itself. So you may get someone calling you for a nuisance. Hey, I hear a buzzer in the room and I can't get in there. What's going on? But anytime you hear an alarm, please react to it. There's a condition with the generator set. If you hear it, you're probably going to say it's low fuel. Go out to generator set, see what the low fuel condition is and why that's there. That concludes this alarm. We are now in the generator room where we have the emergency generator that backs up the entire building. This generator is designed to back up 2 elevators, exhaust fans, fire pump, and egress lighting for this building. On the generator set, we have the engine controller. The first screen is the display for alternator parameters, gives you voltage, amperage, current, and kW. The second screen is our display screen that's going to give you generator alarms, engine conditions, status of the equipment, status of the generator set. It operates through a menu screen. There's a cursor that blinks. There's a cursor that blinks that tells you where it's at. Upon pressing enter, it will give you the acknowledgement of any faults that are on the generator set. Currently, there are no faults. Home brings you back to the first screen. Menu brings you back to the menu screen. Arrow down brings the cursor to engine. Press enter. You'll have oil pressure, water temp, water and oil temp. You also have a display that says more left and more right. There are a total of 5 pages on this display. If you hit enter again, it'll go to the next page, gives you battery charging voltage, and amperage. Next is runtime, coolant level, and fuel level. And then RPMs for disengagement of the starter, things like that going through. The next would be status, which is basically telling us what condition the equipment is in right now. It's currently stopped, time and date. Menu screen again, we'll go over to generator, which is going to basically pick up the same display that's on the left-hand side, showing it on the right. And the ability to interchange those if you need to. Controls, you have a key for auto. Auto in the auto start position, generator can start at any time during a power outage. If you're here, someone's working on the equipment, put the key to off. Right now we're going to get an alarm at the remote annunciator, giving it a horn. Put it back to auto, clears that back up. E-stop, if in the event you have a failure and the engine shuts down due to an e-stop. It's going to go through, it's going to give an alarm. And why isn't the horn going off? I'll have to get that. Horn should be going off right now. So to clear the fault, bring it back out, go to acknowledge, put the key to off, bring it back on. Now the system's back in auto. But you have to put the key back to off to clear the fault, but you also have to acknowledge the fault that it's cleared. And clearing it, these keys are just a quarter turn. So if you have a high water temp alarm, it shuts the engine down, you have to fix the fault, clear it, off, reset, you're set and ready to go again. All the low voltage customer connections are brought into this area. Generators equipped with 3 breakers, 1 breaker here for equipment, 1 breaker on the other side for fire pump, and I think the other one, nope, pardon me, this is the fire pump feed. The other 2 are life safety and equipment. Okay. The engine also has a remote radiator. So on the front of this engine is a cooling system that basically takes coolant from the engine, transfers it to another medium, and then pumps it up to the remote radiator on the 3rd floor. These are the 2 pump controls. These pump controls run off the voltage of the generator set. In the event there's a power failure, a relay will close and tell these 2 starters to start. This circulating pump and this circulating pump is that one there and the one on the other side. You can physically turn them on. All we're doing is moving water. Okay. This one's going. So this one is moving the jacket water. This one's moving the jacket water, which is the first pump. This one's moving the charge air cooler. Okay. So there is an air to water cooler. Since this engine is turbocharged, they cool the air that's going into the combustion system. When you're doing your weekly inspections, Mark will provide you a checklist that'll help you go through what we want to see you keep up with. If you find an issue, document it, get the corrective measures started. Air cleaner is located here. You have a dust screen. Basically, you just want to squeeze this. Just if it picks up any dust or debris, it's going to collect here. Servicing it, just pop the snaps, pull it out, put the new one in. Engine starter. As you're looking at the engine, you just want to look at it cursorily. Look for any oil leaks, any coolant leaks. Engine ECM, priming pump, fuel filters. Oil filters are going to be on the other side. Fill, breather tube. Engine also is equipped with a remote fill station. So this fuel tank is filled from an outside box. City of Phoenix does not allow you to bring a fuel line in the building anymore. Where some generators you just brought it in and you plumbed it right to the tank. They don't allow you. They want you to fill it from the exterior of the building. So we have a solenoid valve. In the event that the tank gets at 90%, it will give an alarm, and I'll show you that display. At 95, it closes this solenoid valve and prevents you from overfilling the tank. When you're looking at this side of the engine, You just want to look at the fan belts, make sure that they're not frayed. Please note, it can start at any time.
Right.
So you just want to look around, look for any cold water leaks. Feeling the engine, you should feel warm to the touch. That just lets you know the block heater's running and the block heater's on the other side, and we'll go through that. But on this side of the engine, all you're really doing is looking for coolant leaks, water leaks, anything that was rubbing or you have a failure coming up. You have your supply and return lines for your fuel and a fuel level gauge. Visually one here, and then you have a percentage gauge on the controller. City of Phoenix limits us to filling the tank to 95%. So, and they did the load bank test and everything else, and you're just a little under 3/4. So right around 80-85%. Okay, we're on the opposite side of the generator set. This side of the generator is all the mechanical plumbing going up to the remote radiator. The remote radiator also has isolation valves. So in the event that you have to service the charge air cooler, any of the pumps, engine hoses, or anything like that, we can isolate the water so you don't have to drain the whole entire system down. There's a couple hundred gallons of coolant that I don't think we really want to replace. I'd rather replace 10 gallons versus a couple hundred. So there's isolation valves going through. Like I said, this is charge air cooler. This is the water lines going in. Top and bottom are the air lines going in from the engine. Jacket water, supply and return coming in, going through a shell and tube heat exchanger. This side of the engine, you're going to have your oil filter. As I said before, just look around the engine, look for water leaks, any type of coolant leaks or anything like that. Engine batteries are lead acid. Recommend checking the specific gravity of them at least once a year. You'll probably end up changing them every 2 years. They typically will last about that long in our heat. This room is not air conditioned as of yet. They do have a fan, so it might get climatized a little bit. Engine circulation pump right here should be hot to the touch or warm to the touch. Right now, this is thermostatically controlled, keeps the engine between 80 and 100 degrees. So it assures that we have a proper, efficient start when it's called a run. This side of the engine, you got your muffler, your turbo, your second battery, and we have a load center. Load center here is running all the accessories on the engine. So you have a breaker for the fill station, you have GFI receptacles, you have receptacles for the coolant heater, another receptacle, GFI outlets, and your battery charger. This panel is fed from a panel in the electrical room, and you can get with CCON, they'll tell you exactly. So in the event that you have a failure with your battery charger, two things you gotta look at. One, is this breaker tripped, or is the breaker in the other room tripped? If the breaker in the other room tripped, you're gonna have the breaker having an issue, and you're gonna probably have a low coolant level temp, or a low coolant temp alarm. That'll let you know that you lost power. You've got two of the same events happen at the same time. This side of the generator set also keeps ATS1 and ATS2. ATS1 is a little 150 amp. ATS2, I believe, is a little 400 amp. This one's feeding all your egress lighting. This one is feeding all the elevators. When you're doing your inspection, verify all the breakers are in the on position. When you're done with your inspection, last thing I do, make sure the key's in the auto and all the breakers are closed. That's basically it for your service and inspection on this side of the engine. We are now in the electrical room, the emergency, basically emergency room for the generator set and all the life safety loads that are in here. The generator breakers feed two transfer switches, one located on this wall, one located on the adjacent wall. The transfer switch here is ATS1 corresponding with ATS breaker number 1 on the generator set. They have identified normal powers being fed from room switchboard number 1 and feeding emergency power from generator number 1 in the other room. Controls on this generator set are set up here. You can arrow down, enter, gives you system voltage, and there's a menu of keys going through. System voltage for source 1, frequency, source 1 is good. Source 2 is 0, which is the generator set. It's not running. Time and date are stamped here. All the displays that are basically being picked up here are also going to be available in the fire command room. Just you have to go through the HMI display. View set point counter, no. Transfer history tells me exactly what caused. So if you have multiple outages and it's all caught and you get nuisance starting at the generator set, is it a utility issue or is it a load issue? So this will tell you if it's a utility issue, if you're losing phase A, phase B, or phase C, or if you're losing frequency. We monitor here at this point. So view set points, yes. So change set points, no. Time delay engine start. Upon loss of utility power, 1 second will elapse before this transfer switch will give the start command for the generator to start. This switch by code has to be up and online in 10 seconds. Fire pump does too, but that's on a separate circuit. Normal to emergency. Once the generator comes to rated voltage and frequency, within 10% of it, the transfer switch will transfer over. Emergency back to normal. Once utility power is restored, it will run for 10 minutes before the transfer switch will release the relay to tell it to go back. In that 10-minute period of time, at 9 minutes and 30 seconds, if there's another blip in the power, the timer will start all over again. It will not continue from that last 30 seconds. So you could be on the generator for 30 or 40 minutes if you have multiple outages during that retransfer period. If you wanted to bypass that time delay and you said, okay, I want the utility back on the generator set, I have other functions I can't, or whatever the cause, there is a function here, bypass, time delay normal to emergency and time delay emergency to normal. You push both those buttons at the same time and it will just go through and, let me clear that. Oh, get out of there. Why is that going through? Why aren't you clearing? Going through the relay. It'll clear out. Well, as you go through, it'll give a timer to go out, and for some reason it's giving a little weird communication. But it will go through and it'll time that out and allow you this switch to go back to utility. You can do the same for the switch over here on this side too. Okay, the next emergency to normal is 10 minutes. Time delay engine cooldown is set for 5. So upon retransfer both transfer switches, the last switch that goes back to utility will tell the generator to shut down. It will run for 5 minutes at a no load condition and then shut itself down and wait for the next event. Frequency, nominal voltage, source pickup, dropout for your voltage settings. And the one I wanted to check, it should be set up on this one typically, is your plant exerciser. Plant exerciser is off on this one. We'll check it on this one. Typically we do it on the life safety switch because it's the one that's always on, and if you had to do a transfer test, you always know it's the life safety switch. Let me see, just for, yes, they set the exerciser up on this switch. We can leave it there or we can transfer it to here. It makes no difference. Okay, so each switch has its ability to start and stop the generator set via an exercise, test mode, duration, pre-transfer. Basically, that's it. Once it gets all the way through, around, language, change time and date, no, reset, no, we're back to normal. Then on this switch, we'll look at the plant exerciser. The controls are still identical. Right now it's on a 7-day exercise. It's a no load transfer, 0, so it's just going to start the generator set. It's going to run every Monday. It's going to start at 9 a.m. Test mode, it's going to run for 10 minutes.
Are there city requirements for that we need to be meeting? Is that
yes,
what it is?
that's what it is.
Set towards that?
Yes,
okay.
It is
Once
minimum.
a week, 30 minutes.
Right now, it's once a week, 10 minutes.
Once a week, 10 minutes.
All they recommend, correct me if I'm wrong, all they recommended is exercise. The duration of exercise is your discretion.
I was getting into frequency, but okay, the duration's up to us.
Is up to
And
you.
you want 10 minutes long enough to get it to heat up and...
Exactly.
Okay.
Yep, bring it up to temperature, get the coolant moving around, get the oil moving around the top of the block, get things like that going through. Then once the timer times out, it will pre-transfer, transfer back. Now, if this transfer switch is also connected to the elevators, there's two contacts. There's a contact for switch position and a contact for pre-transfer signal. The pre-transfer signal lets the elevator know that it's going to switch from one source to the other, and that timer's set up at 20 seconds. So once we give the elevator a command that we're going to transfer, they stop a car, open the door, wherever that is in their cycle. Once the transfer switch transfers over, we close another set of contacts to tell them that they're on emergency. At that point, they only run 2 elevators. The third elevator, if I remember correctly, will come all the way down to first floor and open up, with whatever the protocol is for that. This is the life safety transfer switch, which feeds the life safety panel on high voltage through a transformer to the low voltage panel. On this panel, they have 3 transformers and some generator loads. We've got the pumps and the fan. Let's see, and probably, yep, coolant pumps. This is the panel that's feeding the load center on the generator set and all the circuits for the pumps. So it leaves here, goes to the starter, out of the starter to the pump. So if you have a problem with the pump or starter not having power, this is where it's being fed from. So it has power on emergency and on utility. Then through that, this is picking up all your egress lighting. Generator heater, 120. So this is the panel, yeah, the low voltage panel is picking up over there for the low voltage. So this is the panel. So you have all your elevator lighting, egress lighting are on this panel for your building. And when CCON goes through theirs, they can give you a better idea exactly what those loads are and where they are. But these are the 2 emergency panels that you have for life safety. This is transfer switch number 2 connected to the generator set, being fed from switchboard number 1, normal power. This transfer switch backs up your elevators and all your standby loads in the building. It is feeding 1 EH2, which is your high voltage panel, through a transformer into EL2, which is low voltage. Your panel schedule here, I can read the small font. Jockey pumps, most of it's probably domestic water on here, that type of stuff. Equipment, water pressure, jockey pump.
Supply fans?
Yep, for the stairwells. And then the transformer. Okay. So that's what this is legally required to pick up all those loads. So all the stairwell pressurization fans that you have are being fed from this transfer switch. Then all your low voltage stuff, fire alarm, fire command, pumps, MDF room, fire pump room, AC. These are all the low voltage loads keeping those rooms and those equipment up and running. And that's all I have for that. We'll go do the fill station and we're done. Okay, now we're at the remote fill station for the generator set. When fuel is required for the tank, this is the means that City of Phoenix requires us to now fill the tank. No longer are you allowed to bring a fuel line into the building. The fill station is connected to a solenoid valve in the fuel line marked diesel fuel into the building. When an operator connects his fuel line to the port, there's a 90 and 95% alarm. At 90%, it'll alarm, let him know he needs to shut the fuel off. If he fails to shut the fuel off, there's a 95% alarm. That alarm also will activate the solenoid valve, preventing him from overfilling the tank. At that time, it'll also give a horn. Operator then closes his valve, disconnects, cleans up with fuel, close it up, and he's all set, ready to go. Now, when you call for fuel again, or the tank level goes down, if there's any fuel left in the pipe, solenoid valve will open, that fuel will eventually, since it's on a slope, the only fuel that won't drain back to the tank is right here, but it's being held in place by check valve, plus a ball valve. So reducing the risk of any spill. And that's what City of Phoenix wants.
Oh, absolutely.
So any fuel that's left in the line, in that 2-inch line, you probably got another 10 gallons worth of fuel in that line back to the tank. So every time the solenoid valve opens and closes and it gets close to this alarm, it's going to cycle until that valve, until the level goes down and the fuel empties out of the valve.
Now, is this unit set for the 90%, so I know 90% fill?
Yep, it's set for 90 right now, and 95 also. So there's 2 senders in the tank that will set off this light and alarm, letting him know that he's got to shut his fuel off. If he doesn't in time, it's going to just basically close the valve, cavitate his pump, and he's done. This is the remote radiator for the generator that's located on the first floor. This radiator will start at any time the generator starts. It runs anytime that generator is running. In the event that there's a failure and the fan shuts down, circulating pumps are still going, you're probably going to have a little more reserved coolant in there until that coolant level gets to a point to shut the engine down. So in that respect, only when you're doing your inspections, you just want to do a cursory inspection of all the fittings, all the piping going through the wall to make sure that there's no coolant leaks. In service, basically probably once a year, do your grease on your controls. There's a sight glass for both sides of the tank.
Okay.
One side of the tank is for charge air cooling. The other side of the tank is for jacket water. And there's a sight glass for each one of those surge tanks, the tanks there for water level. Also, there's a surge tank 1 more floor up. Because of the ceiling height in here, we had to relocate the surge tank 1 more floor up, and it's plumbed down. Top of the line is the makeup water line for both tanks and the air line to bleed the air out of the system. Since this is the highest point of the system, any air, any condensation, or not condensation, but any air bubbles that are in the system will gravitate to there and bleed out the surge tank. On this side, we fill the system up using water here, and then once this was filled, then we filled it up from the surge tank upstairs. Since this is lower than that, if you open this, we'll have coolant everywhere. Also, on the inside of here, this is the motor starter for the fan and its disconnect. So if you wanted to just get the fan running, make sure it's working, hand off auto, start the fan, turn it off. This starter is controlled by a relay off the generator set. So anytime the generator runs, this runs. So if you are going to do service or do anything on the fan, you don't necessarily have to take the generator offline, but you have to take the fan offline. Good practice, if you're taking one off, take the whole system off. We're now on the 3rd floor of the building where the surge tank is located for the generator and radiator. The surge tank is designed to provide makeup water and thermal expansion of the system. While the system is running, there's a makeup line for the jacket water and another makeup line located here for the charge air cooler circuit. Each side of the tank is split in half. Each tank is given a level gauge, so it will give you exactly where it's sitting, and then you have a sight gauge. Recommend at least once a month come up here, just make sure this is full of coolant, and during if we go through and do quarterly inspections and stuff like that, we can provide a coolant top-off service. It will burp some coolant because there's probably air bubbles in the system that just haven't migrated their way out. So as that coolant level comes down, just keep an eye on it, the level, and gets low, coolant goes in it. That's basically about it. If you don't see it all over the floor downstairs, it's just equalizing. Expansion tank, in the event that the thermal expansion downstairs causes the water to expand, it's going to collect in here. Whatever it can't hold here, it'll bleed off into the tank, just like your automobile. Closed circuit covers that fuel or coolant. When you're doing your inspection on this side, you just want to look for a water leak. Everything is soldered copper fittings, so I don't expect you to have any type of failures. But just where there's a connection, just visually inspect it. If you see coolant leak on the ground, something happened. Correct the measure. And that concludes the radiator.